In 3.2, we're solving quadratic equations. So the first type of quadratic equation we're going to do is one like this that can be factored. There is a worksheet in Canvas that describes the different techniques for solving quadratic equations that you could use as a resource. But if we have one that can be factored, we want a 0 on one side and we want to factor the other side. So to get an r squared, that would be r times r. Since that term's negative, that would be a negative times positive. And we're looking for what numbers multiply to make 16 and have a difference of 8. So that would be, a difference of 6. So that would be 8 times 2. Since the middle term needs to be negative 6, then we need the 8 to be the negative one. Notice negative 8 plus 2 is negative 6. So if we were to multiply that out, we would get that trinomial. So remember the zero product rule. If we have a product on one side, 0 on the other side, the only way that can be true is if this is 0 or if that's 0. So we say, what makes the first factor equal to 0? And what would make the second factor equal to 0? If neither one of those are 0, then two non-zeros multiplied together could never make 0. But if one of those numbers is 0, 0 times anything is 0. So we want to find out, how can that be 0? Because if that's 0, 0 times the other factor would still be 0. And how can that be 0? So set each factor equal to 0 and solve. So for this one, add 8 to both sides. So we get r is 8. For this one, take 2 away from both sides and get negative 2. So if factors, that's often the shortest way to solve that quadratic equation. Now this one doesn't factor. This one is a sum of squares instead of a difference of squares. But sometimes we're able to isolate what's being squared. So note if we separate the 81 from the squared, we would have x squared equals negative 81. And then to get rid of a square, the opposite of squaring something is to take the square root. So those cancel. So we get x equals, if we take the square root of both sides, we have to include plus or minus. And that square root's imaginary. Square roots of negatives are imaginary, and the square root of 81 is 9. So notice we still get two answers. We get that x is 9i, and x is also minus 9i. In my math lab, it's probably going to get you to write your solutions separated with a comma. So on the test, this would be okay, but otherwise, you would need to do it this way. So we've done factoring, we've done taking the square root of both sides. So sometimes we run across one that doesn't factor, and notice on this one, if we try to isolate the square term, we would have a variable on the other side. So we can only do the square root of both sides if when we isolate what's being squared, we have just a number on the other side. So in this case, we're going to use the quadratic formula. And remember, when we have a quadratic equation in standard form, meaning we have the x squared term, and then the x term, and then a constant, and a 0 on the other side, then we can use a formula to find out the solutions. So it's the opposite of the middle coefficient, plus or minus the square root of that same number squared, minus 4 times AC, all of that over 2a. So we have to have it in standard form, which has 0 on one side, and then we have no parentheses or anything on the other side, and it's in descending order. So to get it in that format, we have to take 1 away from both sides. So that gives us 2x squared minus 13x minus 1 equals 0. So that would be A, B, and C, and the signs go with the numbers. So the 2 is positive, the 13 is negative, the 1 is negative. So X is the opposite of negative 13, because that's B, plus or minus the square root of negative 13 squared, minus 4 times A, which is 2, times C, which is negative 1. All of that over 2 times A. So that is the solution. We just have to simplify that to get it into most simplified form. So negative 13 squared, that's negative 13 times negative 13, that would be 169. Negative 4 times 2 times negative 1, 2 negatives make a positive, 4 times 2 is 8. So underneath the radical, that would give us 177. Out front, we would have 13, and then 4 on bottom. Now, if that square root, excuse me, simplifies, then we would want to simplify it and see if this reduces any. Now, I don't know off the top of my head if that square root simplifies, but I know 177 is not divisible by 2, but by adding the digits together, 1 plus 7 plus 7, we get 15, which is divisible by 3, and that's a shortcut to find out if 177 is divisible by 3. So 3 goes into that. 3 goes into 17. 5 times, with 2 left over. 3 goes into 27. 9 times, and I believe that's prime. So there are not going to be any factors under the radical that we can pull out. So that's as far as we can go. On the test, I would be fine with that answer, but in my math lab, it's going to ask you to write this as 2 answers separated with a comma. So we would do 13 plus root 177 over 4, comma, 13 minus root 177 over 4. The next question asks us to find the zeros of a function. And what that's asking for is what number can we plug in for x and it make our function come out to be 0. So how are we going to do that? Well, we're going to set our formula, our function equal to 0, and we're going to find out what x's make that work. What x's will make our function 0. Well, it doesn't appear that this one is going to factor. So we use the quadratic formula again. So it's the opposite of b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So that gives us an 18 out front. And then negative 18 squared, which is 324. Negative 4 times 1 times negative 4, that's a positive 16. So that gives us 340 under the radical, 2 on bottom. So whatever that makes, those are the zeros of our function. So let's see if we can simplify the square root of 340. So 2 goes into that 170 times. 2 goes into that 85 times. That's divisible by 5. And that's 5 times 17. That's prime, and these are prime. So remember how we simplify a radical. If we have the same factor underneath the square root twice, we can pull that number out. Anything that only appears once has to stay underneath. So we have a 5 and a 17 underneath. So we leave 5 times 17 under the radical, and then we put the 2 out front. Now we have to be careful at this point. This is a common mistake. A lot of people want to cancel those 2's out like that, but that doesn't work. 2 is on top is part of a term. We can't use a term to reduce a fraction. We can only use common factors. So we could divide each term by 2. We could do 18 over 2 and 2 roots of 85 over 2. Or we could factor the top. 18 and 2 have a common factor of 2. So pull a 2 out front. The 2 on top, the 2 on bottom cancel, and that leaves us 9 plus root 85 and 9 minus root 85. So those are the 2 zeros of that function. Those are the 2 zeros. Now they ask us on our graph here, they give us a different function. They don't really give us the formula for it, but they ask us to find the zeros and the x-intercepts. So the x-intercepts, that's where we touch the x-axis. So the x-intercepts are, let's see if we can count this. That's 1, 2, 3, 4, 5, 0 is the one on the right, and the one on the left is 1, 2, 3. Looks like it's negative 4, 0. So it looks like those are the x-intercepts of this graph. The zeros, remember what a 0 is. It's what number can we plug into our function and our answer be 0. In other words, what x can we plug in and our y be 0? Well, notice that's what x-intercepts are. That's an x value that goes with a 0 for y. So the x-intercepts are the entire ordered pairs. The zeros are just the x values. Negative 5 makes the function, makes the y 0. Negative 4 makes the y 0.